In this experiment, we used the spectrophotometer to measure absorbance and determine concentration using the Baeyer-Lambert law. We first transfer a small amount of solution into the cuvette, making sure not to overfill it. Next, we zeroed the spectrophotometer using a blank to ensure accurate readings.
We're going to put our blank in, arrows facing this way so the light hits it. We're going to slide it in the slot.
Notice that we wiped the clear sides of the cuvette to remove fingerprints that could affect absorbance. The cuvette is placed with the clean sides facing the beam and the lid is closed before scanning.
We're going to zero it. Hopefully it works, unlike my practical. Okay. And it works, unlike my practical. Okay.
Again, here we wipe the clear sides of the cuvette to remove fingerprints that could affect absorbance. The cuvette is placed with the clean sides facing the beam and the lid is closed before scanning. We scan across all wavelengths to determine the lambda max, which is the wavelength where absorbance is highest. Scanning all wavelengths allow us to identify the optimal wavelength for accurate quantitative analysis. This data is quantitative because it provides numerical absorbance values, while the shape of the spectrum provides qualitative information. Next, the Baeyer-Lambert law is A equals epsilon times B times C. A is absorbance, epsilon is molar absorptivity, B is the path length, and C is concentration. As concentration increases, absorbance increases proportionally. If the spectrophotometer is not properly zeroed, absorbance values will be artificially high.
Here the graph shows our lambda max is sitting around 640. That means that's...
While Caden regroups, now is a great time to mention, as you will see next, we record the absorbance values in our notebook, ensuring all samples are labeled and significant figures are correct. Lastly, cleanup. After recording data, we carefully remove the cuvettes, as you've seen, and clean our workspace. And now, back to Caden.
Alright, so here's our lambda max. It's in around 640. The lambda max is where the substance absorbs the most light. So it absorbs the most light, about 640 nanometers.
Honestly, yeah, just go to the application.
All right, guys, so keep in mind, while we do all of this, we're getting absorption values because the Baeyer-Lambert law tells us that absorption and concentration have a direct relationship. So when we can find the absorptions of these samples in the cuvettes, we can use those to figure out the concentration because they're directly related. That's just something to keep in mind here and learn from this.
Make sure the arrow is pointing either left or right, not top or bottom. Then you start it, name it, just do pink. And then you get a reading.